Okay, so we are now going into the discussion of energy. So energy in a nutshell is the capacity of doing work by a body. Okay, so energy, remember, is a scalar quantity. The energy required to do 1 joule of work is called 1 joule energy. 1 kilojoule is equal to 1000 joules. So remember that 1 joule of work is equal to 1 joule of energy, which means that if you don't have 1 joule of energy, you won't be able to do 1 joule of work. Parang ganon. So energy developed by a body due to work done on its is called mechanical energy. And there are two types. First is the potential energy, then there is the kinetic energy. So we'll discuss first potential energy. So potential energy is simply the energy stored as the result of an object's position. For example, we have here the heavy ball of a demolition machine is storing energy when it is on the elevated position. This stored energy of position is referred to as its potential energy. Similarly, a drone bow, such as this one, is able to store energy as the result of its position. When assuming its usual position, not drone, there is no energy stored in the bow. Yet when its position is altered from its equilibrium position, the bow is able to store energy by virtue of its position. The stored energy of position is referred to as the potential energy. Potential energy is stored energy of position possessed by an object. So there are two types, which is the gravitational potential energy and the elastic potential energy. Start first with gravitational potential energy. So the formula for that is PE, grav, or potential energy, gravity, is equals to the mass of the object multiplied by gravity and then the height, or simply PE grav is equals to mgh. In the above equation, m represents the mass of the object, h represents the height of the object, and g represents the gravitational field strength, which is 9.8 Newton per kilogram in terms of Earth, sometimes referred to as the acceleration due to gravity. Remember that 9.8 Newton per kilogram is also equals to 9.8 meters per second. The typical gravitational multiplied by Newton. Remember that gravitational potential energy is the stored energy as a result of an object's vertical position. The energy is stored as the result of the gravitational attraction of the Earth for the object. The gravitational potential energy of the massive ball of a demolition machine is dependent upon two variables. First is the mass of the ball, meaning the more massive the ball, yung pambabangga sa pader, the higher its potential energy is. There is also the direct relation between the gravitational potential energy and the height of an object. Meaning, the higher the object is elevated, then the greater potential energy it possesses. These relationships are again expressed in this formula. So, to determine the gravitational potential energy of an object, a zero height position must first be arbitrarily assigned. Why is it arbitrarily? Kasi there is no wrong, but you should think of it. Usually that is the ground, this one. So when we say arbitrarily assigned, it means that this would be the what we say the zero position. So in terms of our Cartesian plane, so usually this is where we should start, this one. So why is it arbitrarily? Kasi for example, if your situation is at a table and dito nag-start yung inyong measurement at the top of the table, okay, you should not use the ground as your zero height position because according to your problem, that's the table. Okay? So it depends on the situation. So since the gravitational potential energy of an object is directly proportional to its height above the zero position, doubling the height means doubling the gravitational potential energy. And tripling the height means tripling the gravitational potential energy. Simply put, the higher the object is, such as this first scenario, it will possess a higher potential energy because it's higher in terms of the zero height position. And this one would be the lowest since it has the lowest in terms of the zero height position. Let's just say this is 1 meter, this is 0.8 meter, something like that. And this is like 0.9 meters. Parang ganon. Okay, to check, let's have some activity here. We have to use the principle discussed to determine the blanks in the following diagram. Knowing that the potential energy at the top of the tall platform is 50 joules, what is the potential energy at the other position shown on the stairs, steps, and the incline? Okay, so for this, I'm going to give you 3 minutes to chat your answer. Write down A is equal to blank, your guess in terms of joules. B is equal to blank, C is equal to blank until F. Please make sure that your answer is magkakasama na A, B, C hanggang F at hindi siya putol-putol. Okay? So again, if the height here is 50 joules, the potential energy of the ball here is 50 joules, and in the ground here, the potential energy is 0 joules, what will be the potential energy of A, B, C, D, E, and F? Okay? 3 minutes starts now. Last 1 minute. Okay, so let's reveal our answers. A would be 40 joules, B would be 30 joules, C would be 20 joules, D would be 10 joules, E would be still 0 joules. Why? Because according to our PE, it determines with the height, and if this is our zero height position, there will be zero height, which means there would be 0 joules. Meanwhile, F also the same in terms of potential energy. We will have 0 joules because it's already on the ground. So that's how you determine them. Okay, in terms of elastic potential energy, this is the second form of potential energy that we will discuss. Elastic potential energy is the energy stored in elastic materials as the result of its stretching or compressing. Elastic potential energy can be stored in rubber bands, bungee cords, trampolines, springs, a row, or drawn into a bow. And the amount of elastic potential energy stored in such a device is related to the amount of stretching of the device. For short, the more stretch, the more stored energy. Springs are a special instance of a device that can store elastic potential energy due to either compression or stretching. A force is required to compress a spring. The more compression there is, the more force that is required to compress it further. For spring, we have a different formula, which is this one. P is spring is equal to 0.5 multiplied by K, which is the spring constant, um, multiplied the amount of compression squared. So that's how we do it. So, magkakaroon tayo ng other, I think so. We're going to have another discussion here that relates to the Hooke's law. So, I'll just summarize it. Summarize, potential energy is the energy that is stored in an object to its position relative to some zero position. An object possesses gravitational potential energy if it's positioned at a height above or below the zero height. An object possesses elastic potential energy if it's at a position on an elastic medium other than the equilibrium position, which is this formula. That's it for elastic potential energy. We're now going to proceed with kinetic energy. So, kinetic energy is the energy in motion. So, an object that has motion, either vertical or horizontal, has kinetic energy as long as as it is moving. There are many forms of kinetic energy: vibrational, due to an object's vibrational motion; rotational, due to an object's rotational motion; and translational. This is the energy due to the motion from one location to another. So you have vibrational, rotational, and translational. And to keep matters simple, we will focus upon translational kinetic energy first. So the amount of translational kinetic energy that an object has depends upon two variables. That's the mass of the object and the speed of the object. The following equation seen on this slide is the equation used to represent kinetic energy, which is Ke is equal to 0.5 multiplied by mass velocity squared, whereas m rather is mass of the object and v is the speed of the object. This equation reveals that the kinetic energy of an object is directly proportional to the square of its speed. That means that for a twofold increase in speed, the kinetic energy will have to increase by the factor of 4. For a threefold increase in speed, the kinetic energy should increase by a factor of 9. And a fourfold increase in speed, the kinetic energy will increase by a factor of 16. Kinetic energy is dependent upon the square of the speed. As it is often said, an equation is not merely a recipe for algebraic problem solving. This is also a guide for us to think of the relationship between the different quantities. Remember that kinetic energy is a scalar quantity. It does not have a direction, unlike velocity, acceleration, force, and momentum. The kinetic energy of an object is completely described by magnitude alone. Like work and potential energy, the standard unit of measurement for kinetic energy is the joule here on your screen, which is equal to 1 kilogram per meter squared over second squared. So that's the unit for kinetic energy. So to further understand and better explain this, we're going to have some example problem solving in terms of kinetic energy. So for our first part here, we have to determine the kinetic energy of a 625 kilogram roller coaster that is moving with a speed of 18.3. So that will be the formula for kinetic energy is again KE is equal to 0.5 multiplied by mass multiplied by velocity squared. So let's just write 0.5 here, or 1/2. Multiply it by the mass, which is 625 kilogram. Remember that the unit should be in kilogram. 625. I won't write the unit anymore, the unit symbol, to make this cleaner. And the velocity or the speed rather, since this is a scalar, is 18.3. So right here 18.3. Plug that in your calculator. Your answer should be kinetic energy is equal to 1.05 times 10 to the 5 joules. So again, the unit is in joules. So that's it. That's how simple it is. Okay, let's have another example. Okay, for second and the last problem, Miss Dive, a former diver, had a kinetic energy of 12,000 joules before hitting the pool. And if Miss Dive is 40 kilogram in mass, what is her speed before hitting the pool? Let's write down our formula. So this is now, you can also write 1/2. Let's just write 0.5 mv squared. But sometimes you're going to see 1/2. Pareho lang naman yun. Okay, so this will now be a matter of algebraic processes. So KE would be 12,000. Let's write it down here. No unit na. And then 0.5 multiplied by the mass, which is 40 kilogram. Then we want to isolate V squared. We can multiply this first. It would be 20. So 20 V squared. So this is 12,000. Divide both sides by 20. 20. So we're going to have 600. So that 600 joules is equal to V squared. However, again, we're searching for speed, which is V. Para matanggal yung squared, squared at both sides. Cancel. So V now is equal to 24.49 meters per second, because we're asking for the speed. That's it. So that's how you search for the speed. If you're trying to search for mass, same process. You just have to isolate M. That's it for energy. In our next discussion, we're going to discuss power.